Okay. Good afternoon, everyone. Please go to your Moodle Week 7 and download linear regression, Jupyter Notebook, and also, yeah, everything. But we already had we already looked at the PowerPoint in the previous class, but today we don't. So I give you 5 minutes to do 2 things. First, download these materials. Also, go to Databricks and run a new cluster. Which, again, from next class, please start doing from before the class because sometimes it takes a lot of time to be run. Again, I think you already know that, but if you want to make a new cluster, just on the left menu, go to compute and just create a cluster and just leave everything as default. So if you're able to download it, I think you already know how to import the Jupyter Notebook and data. So if you want to import the data, I'm sorry, the Jupyter Notebook, go to Workspace. So when you click on Workspace, you see your ID. So just specify which ID you want. And next to, I mean, here, this is my ID, which is my email address. So there is a like downside button here. Just click on it, import, and here just click and browse your Jupyter Notebook and just find it and bring it here. So Jupyter Notebook is IPYMB. So after you press import, it should be one of your notebooks in here. I have too many notebooks, but for you, most likely, there's just 1 or 2 notebooks. Again, for tables or files, if you want to import it, just go to data. Okay. On data, create, when you select data, click on create table. And you shouldn't do anything else, just select these 2 tables or files, drag and drop, and that's it. Again, you don't have, but just keep in mind, there's addresses here. So for me, it's -3, for you shouldn't. because I already brought it like 3 times. So if you bring it multiple times, every time just -1, 2, 3, 4, 5. And this is the so these addresses are from Hadoop ecosystem, so a Hadoop distributed file system, so which we get access to our Jupyter notebook. So as you might see, it's much easier than AWS or local instance, which you should just set up everything. Then you bring files through Peak. So you might remember we load the data and use the Peak. So, or a Scoop, or there's other technologies. But here you just drag it up, that's it. So most likely you just have three things to work with. With compute, you run a new cluster. With workspace, selecting your ID and import, you can import a Jupyter notebook. With the data create table, you just upload your data. So just these are the most frequent items that you work with through Databricks. So your competition due date is today? Okay, so to mercy of your friends who's attending Adobe Challenge, I don't post any homework for this weekend. So I know Mondays is a break too. So enjoy just your weekend. I think you can explore around, probably because the COVID is much better now. You can find so many fun these days. Especially from your friends from Massachusetts, I think you know some good places and can tell your friends. Okay, so hopefully by now, by the way, have you been able to have a cluster running? Okay, today is much better. I remember last time it was very hard to run a cluster. So not just this class, so many around the world. So frankly speaking, I run my cluster like 8 a.m. today. So to be sure, when I come in the class, I have this running. So let's wait like a couple of more minutes. So hopefully. Okay, I think some of you have the ability to work with the cluster right now. So first we need to bring our Jupyter notebook. So how? Again, you go to workspace, you find your ID. So I just have one user ID. And today notebook is linear underline regression. Just click on it. So most likely if it's first time, you need to assign a running cluster. How? Top left, do you see for me, there's a green button here. My cluster name is 1, for you might be your name. So here, just click on this cascade button and select your running cluster and just assign it to your cluster. Okay, let's at least look at the data. Hopefully by then, most of you have a running cluster. So if you go to, let me just open your files. So click on web sale. .csv, web underline sale. Okay, for the next weeks, please do some of your practice, how to run a cluster, how to bring your data, how to bring your Jupyter notebook. So, because next class I don't teach it anymore, so I would assume you already know how to be able to work it. So this is a web, it's something, have something, not exactly, but it could be somehow near to the goal of Adobe Challenge. So they have some amount that people spend on website, but here we have the names. So usually the name, it should be anonymous. You should have just one ID. But here we have their email, address, avatar name, average session length, time on app, because for the data store, there is two options, either app or website, length of membership, and yearly amount spent. We are not sure about the unit, so probably yearly amount spent is in dollar, length of membership maybe year, time on website, and time on app either could be day or month, day or hours, I'm not sure. So average session length, it's probably minutes, how much time, average session time that they spend either on the app or the web. So we could guess it could be minutes, I guess, these three columns. And this column could probably in year, and this one in dollars. So what can we do? So first of all, these two are not useful. Email and address, maybe we don't work with them. Avatar, don't think it makes sense to use it. So most likely you can use these four columns, trying to predict the amount that they spend on a year. So this is our first data set. Let me just close it. Open the, what's that? Okay, simple linear regression underline DAT, or data.txt. So if you open it, I opened with the notebook. So it's actually looks weird, right? So on the left side, you have some, first of all, I don't have any header. Also look at, so I have one left column. So it's just some a continuous variable. On the right side, I have key one in front of, is like a dictionary of Python. So in front of one, I have a number, 2, 3, 4, up to 10. And it's just repeated for all the rows. This is actually one of the data formats that is Spark friendly. So it's not that much, when you look at it, it just looks strange, but basically just means, so let's say on the left side is your dependent variable, and right side you have 10 columns of independent variables. So 1 to 10 is just basically 10 columns. So we work with these two formats. So the second format, the second file that I'm showing, is not that much common, but you might see somewhere is one of the ancient Spark format files that is just getting fade out, similar to RDDs. But just as an example, I just want to show there is a format. So although it looks weird, but maybe if you work with some old data, you might see it somewhere. Okay, so I think everybody should have a running cluster, right? Is it loading? Maybe you can refresh your page. Okay. Sorry, sometimes. So, okay, so in the first block, we just import a Spark session. And you might remember, this is a package that has both Python code and SQL-like codes. And we build everything on top of that Spark session. So it's basically entry point. And also I'm importing a new package which name is just random. And later I'll show you, it's just for random number generation. So I import them. The second one, I make it basically, you don't see the usage of it for now because we just have one function. one job. Also, we just have one node. But sometimes, let's say you work with several Jupyter notebooks, and they might take like a long time to run. So my app name here is LREG, or linear, stands for linear regression. Maybe I just let it run and I look, I open another Jupyter notebook, another cluster, and run it. So each time when I look at my CPU usage or system usage, I can see I have several app names, and each time for each of them, how much calculations or how much time is spent on my, let's say, supercomputer. But here it's just one app, so and we don't have access. But I just want to show you there's such a thing that you identify app names. So later you can look at the progress of your codes, and app name is just like an ID name, something like that. So I've told you we have MLlib. So from MLlib, I'm importing linear regression function. So from Spark ML regression, import linear regression. Okay, next part. Look, I'm saying that spark.read.format, and I said the format name is libsvm. It was the weird format that you just saw, the name of that format, which is a Spark friendly. So Spark, you can easily work with that format. So, but again, it's just fading out. So the name of that weird format is libsvm, and .load. And in load, I'm just showing the address on my Hadoop ecosystem or Hadoop distributed file system. So I think it should be straightforward, and let's look at the data. So as you see, data has two sections. One is label and the one features. And as you see, under the feature column, it has 10 columns, which it's a sort from ID of 0 to 9. So again, it's not human friendly, but Spark can easily work with that. Although I'm showing here, still doesn't look that much great for human observation. Any questions so far? So again, we just saw two formats. One is more human friendly. The second one is not that much great, but there's such a format that in the real world scenarios, you might see some people use. Okay, in the next section, I'm making a random seed and randomly divide my data into sections, train and test. 70% for train, 30% for test. So can anyone remember what's the point of running a random seed function?
So when you can get the same results every single time you try to run the code instead of just randomly sampling it and getting different values every single time.
Yeah, that's correct. Thank you. So let's, okay. There's a typo instead of why, where, it should be what. What would you say if you get different results with different random seeds? So let's say your result is very different. So sometimes your accuracy is 90%, another time with another random seed, 60%. What would you say? Yeah, so one of them could be overfitting. But more importantly, when you use different random seeds, you already expect your result should be a little different, but not too much. Let's say one time 90%, another random seed 60%, 70%. It just means you don't have a reliable model. So the goal of training an algorithm is just using for future prediction. So you should have a reliable model that you can trust in future. But you see, with just a different random seed, your result is drastically different. So it just means you don't have a good model to work. So if you might remember, I had a similar example in business visualization class. So I changed random seed and the result was so bad. So every time it's just changing drastically. So can anyone remember, so what is another way that we can evaluate the reliability of our model? So we need to evaluate, we need to be sure. So the results are not random. So every time I have a good result. Yes, cross-validation. So randomly you divide your data in 5 different folds, and each time you pick one fold as a test and the remaining fold for train. So when you evaluate 5 times and you see in each fold you have similar and high accuracy, it seems we have a more reliable model that you can use this for future prediction. Okay, that's really good. Okay, let's do the random seed. And okay, next block, I just defined my linear regression model. So it's very straightforward. So as you see, I already brought linear regression function. I'm saying feature columns are features. Label column is just what is in my label, and make a new column with the name of prediction and do your prediction. So as you see, it's very autopilot for PySpark because I didn't have to name my columns. It already made the names by itself, and just assume that where is the location of my features, where is the location of my label. So for this reason, I'm saying that libsvm is a Python friendly. Just everything is set up in the autopilot way. You don't have to rename columns and pick everything. It's already set. But again, it's not that much great for your observation.
Will the prediction column will take something from each column?
So your label column would be used for training your model, and prediction column, it will be created by PySpark.
Okay.
So the first two should be like this because this is how your data look like, but you can rename the last column. So you can say prediction Kelly or any other names that you want. So after developing my function, I just need to apply it or fitting on my train set. So it has, again, 2 sections. First, you define your function with, when I define my predictive function, predictive object, with the name is array. Next block, I just apply it or fit it on my train set. And finally, in the last block, so as you see, there's some similarity with Python. So you define the format that you want to see the results. For example, I said print it. And when you print, you should have these words, model coefficients. And within these 2 curly brackets, put this value in, which is, I put it here. So this value in the parentheses, format something. It would end up being in this curly brackets. So as you see, I just said format is a string, and just from previous object, which was lreg fit, get its coefficient. So the first print is just printing the coefficient of the linear logistic regression, linear regression model that I already fit. Does anyone remember what does print /n means in Python? Next time. Okay, I'm glad you already remember many parts of the Python. And next one, again, making a format of, why are you laughing? So in the last line, I just want to print the intercepts. Yeah. This one?
On the command 7, the result is
It's just internal of Spark. So there is nothing to print. It's just showing what it did. I mean, I'm not very sure what is going on, but it's something should be on the background of your Spark. So let me just open it. Yeah, there's nothing to view. So sometimes, yeah. Most likely just internal calculation of Spark. So for me, it doesn't show. You said sometimes it shows, right? Here I don't. Sometimes if you get error, I guess it just shows the log file, so you can just look at it, see what is going on. But here, it doesn't show me anything. Okay, so these are the coefficient and intercept of my model. So having said that, what I can say, I have too many variables, or I use 10 columns to make a linear regression. So, does anyone remember when you have too many variables, what would endanger your model? Yeah, overfitting. So I have 10 variables. We try to fit a simple linear regression. Sometimes you might have get result, but it's prone to overfitting when you have too many variables. Okay, so let's look at the result of our train set. So with summary, I can bring the object into model summary. So I save it here. From summary, I want to look at the residual, and with .show method, you can see results of your residuals. Is that, it's still, okay. Seems pretty high actually. So minus 28, 25, 24. So it doesn't sound great. So this is a linear regression, and the dependent variable is a continuous one. So you might maybe have RMSE and R squared. So let's look at our R squared and RMSE. What can you say from this model if you look at this predictive performance? So RMSE is 10 something and R squared is 0.05 something. Is a very poor model. So R squared is between 0 to 1. Closer to 1 means better fit, but close to 0 means like it didn't worth of that effort that you had. So again, if you see such a thing in your project, you need to try to improve your model. Maybe you do feature selection, trying different models. It seems linear regression is not a good fit for this problem. Maybe you use SVM, neural network, random forest, and other algorithms. So let's with the evaluate method, you can use your already fitted model on the test set, and also similar to train set, we can look at the performance. But we already know the performance should be very poor, because even for the train set, we were not satisfied. So still I get a Spark job. So let me see if this time show me what is. No, this time doesn't show me anything. So we might maybe had the residual in the before that it just shows the residuals. So it's still very high. Now let's look at the RMSE and R squared. Look, this time R squared is even negative. Okay. So let me show it to you. Hopefully your friends over Zoom can see my. So look at this mean, this orange one. So when you get negative, it just means even this orange line is better than, which is the line of mean, is better than your linear regression. So even you're worse than a simple mean as a guess, as a very, so it just means you wasted your time. So it's not, it's even worse than, so it's similar, I mean, not very similar, but you might remember when you have, let's say you have a classification problem, and you have two classes as for your dependent variable. So if you get less than 50% as the accuracy, you said if you toss a coin, your chance is 50%, but you did a model, your accuracy is even less than 50%. So it means you wasted your. So if it's 3 classes, you expect your accuracy more than 33%. It's less than that, means it didn't worth of that much of effort. So I give you 5 minutes to play. If you have questions, ask me, even people over Zoom, or if you want to catch it up, or you also can put your notes. So I think you already know how to put notes in Jupyter Notebook. So you put a hashtag sign in front of hashtag. You can just write your comments. Like here, I put a hashtag in front of that. I just put my comments. So
if I want to create a full, data break, so should I like upload or like?
So go to workspace, create. Yeah. So you go workspace, create, then your ID. So. So I remember when I was a student, it was a DAO competition. It was from Informs. I'm not sure if you're a member of Informs or not. So I got one of the top 5 teams, and I always put in my resume for internship or everything. Yeah, I was in the DAO challenge, and I was from top 5. I was 5, exactly. But I said I was among top 5.
So like if you get like first place, then you say like, oh, I was first. Yeah, we won. First place. But like if you're in top 5, every time like I get like second or third place, I just say like I was in this competition, top 3, top 4. So like if I win, I'm gonna say like, all right, I'm on first place.
Yeah, exactly. Okay, hopefully by now you put your comments, or if you hopefully don't have any questions. So, okay, for test set, I just with the transfer parenthesis test set, I just basically not only predict but also transform to the format that I specified here. So early on, here I said feature, column in the features, label in the label, and when do prediction, make a new column of prediction. So this is the early object, predictive object that I created. Here, down here, is that? Okay. So with transform, I just not only I do prediction, also transform my data to the object that I already created, and with dot show, you can see the result. So I have label column, dependent variable features. Again, you cannot see within features, but you also see your prediction. Even by, if you eyeballing, you see a lot of deviation from label and prediction column. Okay, so let's now bring a human-friendly format, which is CSV. So with the spark.read.csv, you basically identify the location of CSV file on Hadoop distributed file system. With infer schema, you might remember in the first class I said how to make a schema, but here I just said a Spark, just do your guess and bring the schema that you think is fine. And with the header true, I'm just saying that this data has a header. And with print schema, I can see if the structure of the data is correct based on what Spark, PySpark guessed. So, and I feel happy with the guess of Spark, since it made a correct guess. If you're not happy with the schema, please look at your previous Jupyter notebook that I provided, and you can see how to identify the schema that is correct. So again, for your project, you shouldn't just import, and you need to look at the schema to see if it makes sense for you or not. If it doesn't, just make a schema that fits your data. So then look at the data. So if you look at that, it makes, I mean, it's human friendly because you can easily see which columns header you have, what are your data. So it's much better than libsvm in terms of basically human readable. So, but we need to identify extra steps. So in the like libsvm format, you just let it go. But here, you need to make it a Spark friendly. So make it a Spark to be able to read it. Having said that, so I'm bringing importing vectors and vector assembler. It's somewhat similar to label and features in the libsvm format we had it, which we had earlier. Again, the data right now is human friendly. We want to make it, or intuitive for human, but we want to make it Spark friendly. So for this reason, I'm importing vectors and vector assembler. So having said that, so with the columns, you can see the columns that you have. I think it's very similar to Python. Okay, so I'm identifying a new object, basically just convert my CSV file to something that PySpark can work with. So within vector assembler function, you identify what is your input columns and output column. Again, it's pretty much similar to features and label in the previous format. So here you just need to identify who's your independent variable, who's your dependent variable, and your data. So after making your assembler object, you just transform web sale. So web sale, if you might remember, it was just the CSV file that I imported. Now I'm just saying that looking the vector assembler that I have, convert it to or transform it to something Spark friendly. So after identifying which is your independent and dependent variable, you transform your CSV file into, again, PySpark friendly, and with data.show, you can see your data. So if you look at it, so almost everything is same, you just have new column of features. So this column, although looks doesn't look great for you, is Spark friendly. So let me go back to libsvm before. So do you see we have a feature column? For some reason, Spark is easier to work with. So now we have something similar here. We have feature column. Okay, next with the where is that? Okay, so with the select method, I identify which column I need. The only column that I need is the features and my dependent variable. So yearly amount spent is my dependent variable, and features is just, it just has a compact version of the last 4 columns, but this is the only column that I need for prediction. So I select features and yearly amount spent as my basically feature column, and label one. Label just means basically, oh, here, sorry, here first I pick train and test. And when I want to make my predictive object, which is linear regression, I'm just saying which column was for feature, which column was for label. Again, label just means dependent variable. And also say this predictive object has a prediction column that when you do prediction, just record your prediction in that column. The first 2 columns should be like this, because first of all is how we basically transform our data. So your model need to know which are your feature and label ones. And also, but the last one is arbitrary. You can pick any prediction column name that you like. Any questions so far? Okay, let me wait 1 or 2 minutes for your friends if they want to add comments so they can catch up. Okay, so here I'm defining my linear regression object. The name is LReg underline model, and it has one feature column and the one label or dependent column, and also the prediction column. And also, after creating that empty predictive object, I fill it out by fitting on my train set. Similar to before, I want to look at my coefficient and intercepts. So let's do that. So I have 4 predictive column and 1 dependent variable. So it's the reason I have 4 coefficients. So let's look at the performance of model. So this side I look at the RMSE, MSE, and also R squared. Yes. So since linear regression is a good fit right now because we have like I said 98 and also RMSE and MSE, you should look at how many data points you have. If you have too many data points, this RMSE and MSE sounds great for me. The next job, we need to like basically apply down our test set. So with the evaluate method, you apply the fitted model on your test set. With dot show, here I'm just looking at my residuals. So let's see. Yeah. And again, I can see the performance on my test set. Still, R square is kind of similar, 98 something, very close. So your train set is high, your test set is high, and both of them are close to each other. There's no big differences. It seems to be a reliable model, but it's better to do cross-validation. You look at the cross-validation results, but still here we have some good evidences that we can trust this model for future use. Similar to before, with the transform method, I can convert my features, yearly amount spent to something more human-friendly. And sorry, we can apply it and then show it in the human-friendly format. So features, again, it's compacted and it has the information of 4 columns. I have my label or dependent variable, which is yearly amount spent, and also the prediction result. If you do eyeballing, prediction column and yearly amount spent seems to be kind of close, not drastically different. But what are our next steps? So probably we need to do some data preparation. Maybe you add more data. Sometime you may do basically more data gathering and join more data, or in some cases you need to synthesize new columns. What does synthesizing mean? Let's say you make a new column, you look at basically, maybe you make a dependent variable here. Let's say if they spent more than 5 hours, it would be 1, otherwise 0. So you have a dependent new synthesized column, which just means it has 2 categories. If they spend too much, 1, more than 5 hours, less, 0. Or you can do natural logarithm of their average session length. So basically, you apply some functions and synthesize new columns using your previous one. So it could be one way. Again, with n-fold cross-validation, you can have further evidence on reliability of your model. So you may, again, as I said, you need to do 3 different ways, and in 3 different ways, you should try to have a better model. So one, you can, let's say, in the first example, our R-square was very bad. It seems the relationship between your dependent variable and independent variables is not linear. It could be one reason. What can you do? Maybe you try more advanced or more sophisticated model that take care of nonlinear relationship, like SVM. Sometimes is very good, sometimes neural network is good. So basically, you need to just check better models that might be fit better. The next approach could be feature selection. So instead of using too many variables, sometimes it just messes up with your performance. You need to focus on less number of variables that are more relevant. So which we do through feature selection. And the one, tuning the algorithms. So just an example is neural network. Sometimes maybe 2 hidden layers is good. Maybe you need to use 4 hidden or just 1 hidden layer. Or there is basically similar tuning for almost for any algorithms like SVM or like random forest. You can just play with some inside settings of each model. Some cases you need to do resampling, especially when one of your categories is very low. Have you heard about the smooth or upsampling dance? Yeah, you can do that. So you have more balanced data. So hopefully your model would be trained well and you have less bias. And other approaches. So in your next classes, I mostly cover all of them. So we have some Jupyter notebooks that I go cover them, almost all of them. And also I teach you something further. So for example, if I see data preparation, there's some section I cover them up. So by end of this like next few weeks, you should be able to do your project very well. Again, if too many people, 3 people, you need to use 2 platforms, just less than 3. Even 1 platform is enough, so you can do it in Databricks. But again, one important thing, I provide the details further, but again, I need to see you try to improve your models in 3 different ways. Sometimes you can't, but that's okay, as long as you try. And if you have time, try to do install Hadoop ecosystem on several instances so you can feel of what does distributed computing means. Distributed computation. On AWS, it might just charge you, I think it don't charge you too much, even you have several instances, but if you have your like 2 or 3 laptops, maybe you can just run on your own system. So the only difference is instead of having instead of having the Amazon web address, you have localhost, which is 127.0.0.1, and the rest should be same. Okay, any question about today's class or your homework assignments and other things? Okay, so you don't have any homework this weekend. Please, if you think you need to catch up, please catch it up. Like if you need to practice more or you want to spend some time on your Adobe challenge, you also have time. But again, from next week, yes, we would have new assignments, but nothing for this week. Okay, I don't think any question over Zoom even. So yeah, we had a short class today, but from next week, hopefully we get back to the normal sessions and we practice a lot more. So thank you very much and good luck with your Adobe challenge. So hopefully you see something. Cool.